HRPD-X, the project that we're thinking about today, is part of the Endeavour programme at the ICIS Neutron and Muon Source. What does any of that mean? Well, what we do here at the ICIS Neutron and Muon Source is we study materials at the very small scale, at the atom level. We want to study them at the atom level so that we can make new materials. We understand the properties of the materials, we can make new ones that we might use for applications in our everyday lives. And the HRPD-X project is one part of Endeavour. It's going to enable us to study materials in new and different ways.
This is a large investment by the UK government and ICIS's international partners in ensuring that our equipment is at the state of the art and able to make an impact now and into future years, so we can really safeguard our world-leading position to do science across a range of different disciplines. The instruments that we'll build will be more sensitive and will allow faster measurements across the whole range of what ICIS does.
The instrument that we're working on is called HRPD, and the HR stands for high resolution, and that high resolution gives us the ability to see very small changes in the diffraction pattern of crystalline powder materials. And that capability gives us an incredible insight into very subtle changes in the structure of those materials and changes in behaviour that can happen as we change, for example, the pressure or the temperature. And for many materials, particularly those with functional uses in, say, electronics applications, it can be very, very tiny, subtle changes in, say, the tilt of structural subunits inside the crystal, which define their characteristics. And that's what HRPD has world-leading capability to measure. And with the new instrument, we're dramatically expanding the detector dimensions, which is why we need a much bigger building. So HRPD gets its high resolution from the very long incident flight path, and we will therefore be able to, with this new detector array, be able to measure things much more quickly. We'll be able to measure much smaller samples, and we'll be able to study much more complex materials. And so with all of that new capability, we will unlock a whole new range of materials discovery, which is important for building the country's economy.
The interesting bit about this project is that we are delivering it within a very complex operational estate. So it's really important for us as an estates team to make sure that we are in communication with all of our neighbours and make sure that we try to do the project without disturbing the really important complex science that we've got on at RAL at the moment. And that's for the majority of the projects that we do. It's within an operational estate, so there's lots of things that we consider whilst we're tendering the projects and whilst we're delivering those projects as well, and also whilst we're thinking about what the design needs to be.